We will now look at some matrix algebra, along with learning to solve systems of equations with matrices in a different form than we did before. So here we're given three different matrices. We have matrix A, B, and C, and we're asked to perform a series of operations on them. So first we'll look at multiplying matrix A by 3 and subtracting 2 times matrix B. So let's just write that out. I've got 3 times, our matrix A is 0, 3, negative 5, 1, 2, 6, minus 2 times our matrix B, which is 4, 1, 0, negative 2, 3, negative 2. Now with scalar multiplication, which is what we have when we have just a number times a matrix, like 3 times matrix A or 2 times matrix B, we are just going to multiply all the elements in the matrix by that number. So 3 times matrix A, 3 times 0 is 0, 3 times 3 is 9, 3 times negative 15 is, 3 times negative 5 is negative 15, 3 times 1 is 3, 3 times 2 is 6, 3 times 6 is 18. Minus, because I'm choosing to keep it as a minus, could have changed it to plus and multiplied by negative 2, that would work as well. 2 times 4 is 8, 2 times 1 is 2, 2 times 0 is 0, 2 times negative 2 is negative 4, 2 times 3 is 6, 2 times negative 2 is negative 4. So now I have 2 matrices with the same dimensions. They're both 2 by 3 matrices. We're going to subtract them. So we can add and subtract matrices that have the same dimensions. So I'm going to do 0 minus 8 is negative 8. 9 minus 2 is 7. Negative 15 minus 0 is negative 15. So I'm subtracting the corresponding elements. 3 minus negative 4 is 7. 6 minus 6 is 0. And 18 minus negative 4 is 22. And this is our resulting matrix. Negative 8, 7, negative 15, 7, 0, 22. Okay, let's look at multiplying matrix A and matrix C. So I'm going to write out matrix A and matrix C. And we are going to multiply rows by columns. So I'm going to start off in the first row, first column. And I will do 0 times 4 plus 3 times 6 plus negative 5 times negative 2. So I'm looking at the first row, first column. And in the next step, we'll simplify that to give us our actual element that is in that first row, first column. Then I'm going to look at the first row, second column. And we will get 0 times 1 plus 3 times 2 plus negative 5 times 3. Second row, first column, 1 times 4 plus 2 times 6 plus 6 times negative 2. And finally, second row, second column, 1 times 1 plus 2 times 2 plus 6 times 3. So let's simplify. The first row, first column becomes 28. The first row, second column simplifies to negative 9. The second row, first column is 4, and the second row, second column simplifies to 23. And this is our resulting product matrix. You'll notice it has different dimensions from our original matrices. This is a 2 by 2. Now let's look at the product of C times B. So I'm going to write my C matrix, my B matrix, and you'll notice that our C matrix is 3 by 2. It's got 3 rows, 2 columns. My B matrix has 2 rows, 3 columns. And because those middle dimensions match up, the columns of my first matrix match up with the number of rows of my second matrix, I can multiply these. And the outside numbers, 3 by 3, this will tell us the dimensions of our resulting product. So we will have a 3 by 3 matrix as our product. So multiplying first row, first column, 4 times 4 plus 1 times negative 2. First row, second column, I'll have 4 times 1 plus 1 times 3. First row, third column, we'll have 4 times 0 plus 1 times negative 2. Second row, first column, I'll have 6 times 4 plus 2 times negative 2. Second row, second column, 6 times 1 plus 2 times 3. Second row, third column, we'll have 6 times 0 plus 2 times negative 2. Finally, we'll look at third row, first column, negative 2 times 4 plus 3 times negative 2. Third row, second column, negative 2 times 1 plus 3 times 3. Third row, third column, you will have negative 2 times 0 plus 3 times negative 2. Okay, so we'll write our resulting matrix up here. So 4 times 4 plus 1 times negative 2 becomes 14. 4 times 1, actually let's go down. 6 times 4 plus 2 times negative 2 is 20. Going down my first column, negative 2 times 4 plus 3 times negative 2 gives us negative 14. Let's go to our second column, one's in black. 4 times 1 plus 1 times 3 is 7. 6 times 1 plus 2 times 3 is 12. Negative 2 times 1 plus 3 times 3 is 7. And then we'll look at our third column, our purple column. We have negative 2, negative 4, and negative 6. So this is our resulting products. And if we multiply A times B, we notice that matrix A is a 2 by 3 matrix. Matrix B is a 2 by 3 matrix. Those middle dimensions do not match up. So the number of columns of our first matrix does not match up with the number of rows of our second matrix, which means that we cannot multiply those two matrices. Okay, we can find inverses of matrices. So here we have a matrix. It's a 2 by 2 matrix. 3, negative 1, negative 2, 1. I'm going to show you two ways to find its inverse. The one way is using a formula that can just be used for finding inverses of 2 by 2 matrices. And it is assuming that we have a 2 by 2 matrix, which is written in this format. So our first row, first column element is A. Our first row, second column is element B. Our second row, first column is element C. And our second row, second column is element D. Then our inverse can be written as 1 over A times D minus B times C times the matrix where we're flipping A and D. So D is the first row, first column. A is the second row, second column. And we are taking the opposites of B and C. So by the matrix D, negative B, negative C, A. So let's try that. But first let's match up what A, B, C, and D are. So A is 3, B is negative 1, C is negative 2, and D is 1. So substituting into our formula, we have 1 over 3 times 1 minus negative 1 times negative 2. And then the matrix, I'm going to swap my diagonal elements. So I have 1 and 3 swapped. And I take the opposite of my other two elements. And so I have the matrix 1, 1, 2, 3. Let's simplify. We get 1 over 1 times 1, 1, 2, 3. Or our inverse is the matrix 1, 1, 2, 3. Okay, I'm going to show you a second way of finding this inverse. This general method will work for finding the inverse of any square matrix. So we're going to take our original matrix, the 3, -1, -2, 1, and then draw a vertical bar and put the identity matrix to the right. So I've got the 1, 0, 0, 1 to the right. So now I have a 2 by 4 matrix, and I'm going to perform row operations, and our goal is to get the identity matrix 1, 0, 0, 1 to the left of the bar and 4 numbers to the right. So with our matrix, our first goal is to make this 3 a 1. So I'm going to multiply my row 1 by 1/3. I'm not going to touch my second row to start, so my second row stays the same, -2, 1, 0, 1. 1/3 times 3 is my 1 that I wanted. 1/3 times -1 is -1/3. 1/3 times 1 is +1/3. 1/3 times 0 is 0. My new goal is to make this -2 is 0. And I will do that by taking the opposite of -2, which is 2, and multiplying that by row 1 and adding it to my old row 2. So row 2 equals 2 times row 1 plus my old row 2. I'm not touching my first row, so it's staying the same. 1, -1/3, 1/3, 0. And to get my new row 2, I'm doing 2 times 1 plus -2 is 0. 2 times -1/3 plus 1 is 1/3. 2 times 1/3 plus 0 is 2/3. And 2 times 0 plus 1 is 1. Our next goal is to make this 1/3 a 1. To make a 1, I'm going to multiply that second row by the reciprocal of 1/3, which is 3. So my new row 2 equals 3 times my old row 2. I'm not changing anything in my first row, so it stays the same. 1, -1/3, 1/3, 0. 3 times 0 is 0. 3 times 1/3 gives me the 1 that I want. 3 times 2/3 is 2. And 3 times 1 is 3. My final goal is to make this -1/3 into a 0. So I take the opposite of -1/3, which is 1/3, multiply it by row 2, and add it to my original row 1. Where row 1 equals 1/3 row 2 plus my original row 1. Okay, my second row stays the same, 0, 1, 2, 3. And my first row becomes 1, 0, 1, 1. We have our goal. We have our identity matrix on the left. So this matrix on the right is our inverse. So our inverse is the matrix 1, 1, 2, 3, which is what we found using the formula. So either method is fine for 2 by 2. The second method works for any matrix. So we're going to use that second method to find the inverse of this 3 by 3 matrix. So we're going to start by writing our original matrix, 1, 0, 2, -1, 2, 3, 1, -1, 0, and then a vertical bar, with the identity matrix to the right. So here, instead of just 1, 0, 0, 1 for a 2 by 2 matrix, here we have 1, 0, 0, 0, 1, 0, 0, 0, 1. What's important is that we have 1s on our diagonal and 0s everywhere else. So we have the original 1 that we want, but our next goals are to make the -1 and 1 here into 0s. So to make that -1 a 0, we'll take the opposite of -1, which is 1. So 1 times row 1 plus row 2, or row 1 plus row 2. And for row 3, the opposite of 1 is -1, so -1 times row 1 plus my old row 3. My first row won't change, so 1, 0, 2, 1, 0, 0. And to get my second row, I'll do 1 plus negative 1 is 0. 0 plus 2 is 2. 2 plus 3 is 5. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. For row 3, the opposite of 1 plus 1 is 0. The opposite of 0 plus negative 1 is negative 1. The opposite of 2 plus 0 is negative 2. The opposite of 1 plus 0 is negative 1. The opposite of 0 plus 0 is 0. The opposite of 0 plus 1 is 1. Now we want to make this 2 a 1. So we can do that by multiplying our old row 2 by 1/2. My first row will stay the same. My third row will stay the same. And now I'll multiply my row 2 by 1/2. 1/2 times 0 is 0. 1/2 times 2 gives me the 1 I want. 1/2 times 5 is 5/2. 1/2 times 1 is 1/2. 1/2 times 1 is 1/2. 1/2 times 0 is 0. Okay, now I do have the 0 up here. I need to make this negative 1 a 0. So the opposite of negative 1 is 1, and I'll multiply that by the row that has the 1 that I created, which is row 2. So my old row 3 will be 1 times row 2 plus row 3. My first row won't change. My second row won't change. And now to get my third row, 0 plus 0 is 0. 1 plus negative 1 gives me the 0 I want. 5/2 plus negative 2 is 1/2. 1/2 plus negative 1 is negative 1/2. 1/2 plus 0 is 1/2. And 0 plus 1 is 1. My next goal is to make this 1/2 into a 1. And I can do that by multiplying the row by the reciprocal of 1/2, which is 2. So my new row 3 will be 2 times row 3. Okay, we'll do that on the next slide. My first 2 rows won't change. So I have 1, 0, 2, 1, 0, 0, 0, 1, 5/2, 1/2, 1/2, 0. And multiplying my old row 3 by 2, I have 2 times 0 is 0, 2 times 0 is 0, 2 times 1/2 gives me the 1 I want, 2 times negative 1/2 is negative 1, 2 times 1/2 is 1, and 2 times 1 is 2. So now I want to make this 2 into a 0 and the 5/2 into a 0. To make the 2 into a 0, I will take the opposite of 2, which is negative 2, and multiply it by row 3, which is where the 1 I created is in that column, and add it to my original row 1. So row 1 equals negative 2 times row 3 plus row 1. My rule for row 2 will be my new row 2 will take the opposite of 5/2, negative 5/2, multiply it by row 3, and add it to my old row 2. My row 3 won't change, so I'll have 0, 0, 1, negative 1, 1, 2. And for my row 1, I'll do negative 2 times 0 plus 1 is 1. Negative 2 times 0 plus 0 is 0. Negative 2 times 1 plus 2 gives me the 0 I want. Negative 2 times negative 1 plus 1 is 3. Negative 2 times 1 plus 0 is negative 2. Negative 2 times 2 plus 0 is negative 4. And my row 2 becomes negative 5/2 times 0 plus 0 is 0. Negative 5/2 times 0 plus 1 is 1. Negative 5/2 times 1 plus 5/2 gives me the 0 I want. Negative 5/2 times negative 1 plus 1/2 is 3. Negative 5/2 times 1 plus 1/2 is negative 2. Negative 5/2 times 2 plus 0 is negative 5. So we see our inverse right here on the right. So our inverse is the 3 by 3 matrix, 3, negative 2, negative 4, 3, negative 2, negative 5, negative 1, 1, 2. Okay, so another way of solving systems of equations using matrices is to use the fact that we can write a system as using these matrices. We can have the matrix A times the matrix X and set that equal to the matrix B. And if we want to solve for matrix X, we would take the inverse of A, multiplying on the left, and that's important with matrices that we multiply on the same side. And the inverse of A times A would give us the identity matrix or leave us with just X on the left. And we would have the inverse of A times B on the right. And this is the key that we will use to solve some systems. So we are going to solve this system of equations using that method of matrices. So first, we will set up our matrices for matrix A, matrix X, matrix B. A will be the coefficients of X, Y, and Z. So we will have the matrix 1, 0, 2. The 0 in the first row came from the fact that we didn't see a Y term, so it's like we have a 0 of Y. And for our second equation, we have negative 1, 2, 3. Those are the coefficients of X, Y, and Z. And for our third equation, we do not see a Z term, so we'll put a 0 in the third row, third column, but we have a 1, negative 1, 0 filling out that row. Our X matrix is basically our variable matrix with variables X, Y, and Z. And our B matrix contains the right-hand sides. So 6, negative 5, and 6. So our solution will be the inverse of the A matrix times the B matrix. And it just so happens that we found this inverse on the previous problem that we did. So X will be the inverse of A, which we already found previously, to be 3, negative 2, negative 4, 3, negative 2, negative 5, negative 1, 1, 2. That's our inverse of A, times our B matrix, which is 6, negative 5, 6. And this multiplication is defined because we have a 3 by 3 times a 3 by 1. So we will have a 3 by 1 as our result. We will do 3 times 6 plus negative 2 times negative 5 plus negative 4 times 6, which is 4. We'll do 3 times 6 plus negative 2 times negative 5 plus negative 5 times 6, which is negative 2. And we will do negative 1 times 6 plus 1 times negative 5 plus 2 times 6, which is 1. This is telling us our solution, which is 4, negative 2, 1. So this seems very quick, but the reason why this was quick is because we already had our inverse. Otherwise, it would have taken us some time to find that inverse matrix. Let's solve one more. So here we have the system, 2x plus y equals 8, x plus y equals 5. So this is a 2 by 2 system. So writing ax equals b, our A matrix here will be 2, 1, 1, 1. Our X matrix is x and y. And our B matrix is 8 and 5. So we need to find the inverse of A. I'm going to do it the second way I've shown you how to do a 2 by 2 matrix inverse. So I'm writing 2, 1, 1, 1 to the left of a vertical bar, and the identity matrix 1, 0, 0, 1 to the right. I'm going to interchange the rows. Remember, that's an allowable row operation because I want a 1 in my first row, first column. That gives us 1, 1, 0, 1, 2, 1, 1, 0. I literally just exchanged the rows. That's equivalent to just swapping the order in which we wrote that system of equations. Now we want to make this 2 a 0. So row 2 will equal negative 2 times row 1 plus row 2. My first row is not changing, 1, 1, 0, 1. And if I do negative 2 times 1 plus 2, we get 0. Negative 2 times 1 plus 1 is negative 1. Negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 0 is negative 2. Our next goal is to make this negative 1 a 1. We can do that by multiplying this whole row by negative 1. So row 2 equals the opposite of the original row 2. Our first row is not changing, 1, 1, 0, 1. Negative 1 times 0 is 0. Negative 1 times negative 1 gives me the 1 we want. Negative 1 times 1 is negative 1. Negative 1 times negative 2 is 2. Our next goal is to make this 1 a 0. So the opposite of 1 is negative 1, and we'll do negative 1 times row 2 plus row 1. So my second row doesn't change, 0, 1, negative 1, 2. And we'll do the opposite of 0 plus 1 stays 1. The opposite of 1 plus 1 creates the 0 we want. The opposite of negative 1 plus 0 is 1. The opposite of 2 plus 1 is negative 1. So our inverse is right here. 1, negative 1, negative 1, 2. And we can find our solution by multiplying the inverse times our B matrix. So our inverse of A was 1, negative 1, negative 1, 2. Our B matrix was 8, 5. We'll multiply our first row by that one column. 1 times 8 plus negative 1 times 5, and that is 3. And then our second row times the column, negative 1 times 8 plus 2 times 5 is 2. This tells us that our solution is 3, 2.